Now I will introduce Fujii Laboratory. Fujii Laboratory uses system engineering methods such as mathematical programming and stochastic statistics to analyze various issues related to energy, environment, and economic systems, and evaluate related policies and technological development. At Fujii Laboratory, the atmosphere of the laboratory is easy to talk to, regardless of the grade, and we often talk about things other than research, making it a comfortable atmosphere. Around September, there will be a laboratory trip where we can all gather together for a drink, Jenga, and so on, and have a good student life. Okay, next, I will introduce optimal power generation model, OPGM. Trunk power network is modeled and able to analyze the economical power operation and the value of investment and so on. Analyzing the problem in electric power industry under massive penetration of renewable energy is one of the researches using OPGM. When installation of renewable energy expands, shortage of generation capacity, which helps stable power supply, and consignment fee, which leads customers to exit from power system are concerned. Next slide. Using OPGM, these kinds of concerns can be quantitatively analyzed or solution can be suggested. The profit and loss or benefit for capacity to back up the intermittency of renewable energy can be analyzed. There are other ways to use OPGM, such as charging for capacity to avoid negative spiral. Using OPGM, we can estimate the future electric industry and suggest a solution. That's all for explaining OPGM.
Next, I will introduce a global energy system model. This model is focusing on energy system ranging from primary energy production to transport, conversion, and consumption. This model has two types. One is bottom-up. It's able to consider detailed technological characteristics with high resolution for time and region. The other one is top-down. It's able to consider the relationship among plural activity as a whole economic system. I will introduce an example that is mathematical model for energy composition that minimize the total system cost in the whole world. The model divides the world into 82 regions, taking into account of regional differences of energy supply and demand balance, and capacity restriction. Then, by inputting various constraint conditions and exogenous variables, we can get this figure that shows optimal power supply configuration in the future. We can evaluate energy technologies and policies quantitatively by changing model structure and constraint conditions. We will introduce two more models at next movies. Thank you for listening.